All right, but am I still sharing here?
Okay, it's now recording. Yep, and you're sharing.
Okay, so welcome everybody to the Washington, D.C. Chief Technical Officer Meetup. Today we're going to be talking about scaling beyond the Postgres PgBouncer and Pgpool for advanced traffic management. We have Erik Brandsberg with us today. He's the Chief Technical Officer at Heimdall Data. So for our introduction here, we'll just make it real quick. I have a small company here in the DC area. We do software engineering and data analytics. My company is called Coherent Logic, and we have an active contract with the US government at the moment, and one other client that we're working with, which is in the private sector. For networking, if you're interested in joining, we have a Slack group. So that's the first link that you see here. And then the second link is an equivalent group on LinkedIn. If you're hiring or seeking people to help you with your business, in particular with technology related stuff, you can feel free to speak up and let me know, or put the details in the chat regarding what you need. We have another event coming up, which is going to be most likely in late June. It's June 24th is what we're scheduled at the moment. And we have two SEO experts. One is in London and the other one is located in the US. We're going to still try to figure out what those topics actually are, but it's probably going to be about 35 minutes for each person, and it'll take place around lunchtime, Eastern Standard Time. So we're looking at roughly an hour to maybe an hour and 20 minutes long for a nice presentation on SEO related things. Technical SEO being the subject matter around performance and site structure and things of this nature. If you would like to present, let me know. I'm always happy to have speakers and anything around the subject matter of where business and technology intersect, anything that might be interesting for a chief technical officer or somebody who's technical or somebody who's a business person who's interested in technology. I'd be very happy to have a meetup and schedule something. So just let me know. So I'd like to introduce you to Erik. Erik is, as I mentioned, the CTO of Heimdall Data. He's based in Pennsylvania. The product that, or one of the products that Heimdall offers is the Heimdall Proxy. It improves database scale without application changes. It's available in AWS and I believe other cloud platforms. And Erik, you can chime in and let us know what other platforms this is available on. Erik is on LinkedIn, and I posted the link to Erik's profile on the chat. If you want to connect with him, you could, or find his profile there. And let's see what this, okay, so we have a video already, which has also been posted in our chat, which is from 2020. And that is also where Erik has reviewed the Heimdall distributed database proxy. So if you're interested in seeing that product and how it works, we have about an hour-long video there. And then Erik also helped me with this article called Hidden Gems, Event-Driven Change Notifications in Relational Databases. And I thank you very much for that, Erik.
No problem.
We also have Roland with us, Roland Lee, who is the head of product at Heimdall Data. Roland's background is in application networking. He's been a developer and product manager in startups and as well as large businesses. His industry focus has been to increase the performance of internet user data, which I imagine complements what they're doing in Heimdall quite nicely. Roland is based in Palo Alto, California, and I've also included his LinkedIn profile in the chat as well.
Hi, everyone.
Hey. So this is going to be our presentation today. We're going to talk about database proxies intelligently manage database connections to improve performance and scale. And in this session, we'll highlight deficiencies of open source PgBouncer and Pgpool-II that users should know and propose solutions. So I won't read the rest of this. This is basically what we're going to cover. And I will hand over our talk now to Erik, who will take it from here.
Thank you, Tom. Okay, let me start sharing my screen. Okay, thank you, everybody. So as Tom said, we're going to be talking about scaling beyond PgBouncer and Pgpool-II. These are two commonly used proxies that sit in front of the Postgres database. Since some people that have joined are dealing with some other databases as well, I will briefly talk about some of the other proxies as well, although the slides don't cover proxies for other database vendors. This presentation was primarily written specifically for the Postgres community, but most of the content and what we're going to describe applies outside of the Postgres world as well. Okay, so what we're going to talk about. First, we're going to talk about the problems that a proxy can solve. We're going to be looking at comparisons between the different proxies that are available. What use case recommendations, because not all use cases require something like Heimdall. Sometimes the simple cases can just use another product. And then how you actually deploy a database proxy into the network. Now, let's start off with the fundamental theorem of software engineering. We can solve any problem by introducing an extra layer of indirection. Okay, and you see that all over the place. You have different API layers for accessing code. You basically, the more you can abstract chunks of code, object-oriented programming, often easier it is to manage things. So, you guys can hear me, correct? Thomas, you can hear me, correct?
Yes, we can.
Okay.
I can hear you fine.
Yeah, Max was commenting that he was not able to hear us. Max, are you able to hear me now? Okay, maybe Max is having some problems with his audio. Okay, but let's go back to the topic. So we can solve any problem by introducing an extra layer of indirection. If you're accessing your database directly from your application, you're not taking advantage of the capabilities that that extra layer of indirection can provide to you. And a proxy provides the level of indirection, and then depending on what the proxy does, it can solve a variety of problems. So what are the problems? And then obviously this is quite a long list. I'm not going to read through all of them. In the case of Postgres, however, one of the most important issues in many environments is that Postgres takes a fair amount of time to spin up a new connection because of the process model that it uses. And each new connection consumes a fair amount of memory because it allocates off the working memory that you've configured for that connection just by starting it up. So with a proxy, what the intent is to reduce the number of times a new connection is started to the database and reduce the total number of connections that are out there. And that's done with connection pooling and what we call multiplexing. If you're familiar with the Pgpool-II configuration or the PgBouncer world, sorry, they call multiplexing statement level pooling or transaction level pooling. But multiplexing is a term that I've generally used in other protocols like with HTTP and other products in the market. Another prime target that you want to be able to solve is helping to scale the database, either by reducing the need to have as big of a database or reducing the need to have multiple readers. And a proxy can do that with caching and read-write split. Also providing for reliability and ease of management, because if you're pointing at a proxy or proxy layer, then the location of the actual database that's active is abstracted away from the application. So you can move around the active database node on the fly. And obviously there's a whole bunch of other features, but we'll be focusing primarily on those, including the pooling, caching, and read-write split. Okay. So what are the proxy options for Postgres? And I'll also touch on some of the options for MySQL as well. The first and most obvious is just using HA proxy. Now, the problem with HA proxy is that it only handles things at TCP level. It has no protocol awareness of how the database actually works. So this is a very limited set of functionality, and it generally only provides you with the ability to do a failover, say from one active database to another. The next level, if you're in an Amazon environment, is the AWS proxy. Now they have proxies for Postgres and MySQL here, but it is targeted at one feature realistically and one feature only, and that is connection pooling. And the primary use case for using the RDS proxies, the reason why they really created this was to deal with lambdas, where you have one process that's basically opening up a connection, doing a small amount of work and closing connection and going away. So with that model of programming, that hit the databases quite hard because opening and closing connections can be quite expensive. So they, as a result, created the RDS proxies to handle that use case. The next level of functionality would be PgBouncer and the fork of PgBouncer called PgBouncer RR, which is designed in theory to allow read-write split, which is something that we'll be getting into in more detail and later. And then aside from the Heimdall proxy, from a functionality perspective, there's Pgpool-II, which claims to have a very large amount of functionality, but we're going to get into some of the details on why, despite the claim to have this functionality, you don't actually want to use it because it's going to cause you more heartache than it's actually worth. And finally, there's the Heimdall proxy, which is a commercial option. It is the most advanced proxy functionality across the board for any of the databases that are supported. There's nothing that compares to the functionality that we have. And I hate to kind of plug it as a best above all, but I think once we get through the details on the problem statements of what problems these proxies are trying to solve, how Heimdall behaves clearly does rise above the rest. Any questions so far? Okay. So, great big cluster of features and everything else. I'm not going to go through all this, but what I wanted to highlight is the completeness of what Heimdall does in general compared with all the others. The only feature realistically that Pgpool-II or anything has over Heimdall is that Pgpool-II can do replication as well, at least in some situations. The reason why it even supports that, however, is because Postgres at the time Pgpool-II came out did not have any sort of replication. So there were a variety of different solutions to that problem that were built around various methodologies. And Pgpool-II was one of the ways that people got around Postgres not having replication. It's still supported today, but now Postgres has several different types of replication that it supports. So it's a very much not needed. And from our perspective, it's just overkill to try to even do it on the proxy. And there are problems with it as well. There are certain situations where you cannot do replication through Pgpool-II. But connection pooling, pretty much everybody has, aside from obviously HA proxy. I'm going to discount HA proxy for pretty much everything now. Caching with auto-invalidation. Pgpool-II claims it. We'll get into that claim in a little bit. Read-write split. PgBouncer RR claims it. So does Pgpool-II. But there are gotchas. You don't want to use it. Okay. But everything else, just on the slide, you can read over when we do the recording. Okay. Let's talk about connection pooling in detail. Basic connection pooling the intent is actually a little bit different than what most people think of. They think, oh, connection pooling reduces the number of connections to the database. And that's true in one sense, but not in the other. It reduces the number of connection open and close events. But basic connection pooling, as most people think about it, doesn't actually reduce the number of absolute connections at any given moment. It just reduces the open and closes. In order to reduce the number of connections, you have to add additional functionality, which is very advanced, and that's either the transaction pooling or what we call multiplexing. The idea is that you treat SQL as a stateless protocol, which is not always the case. If you're outside of a transaction, if you're in auto commit mode, then effectively the idea is every query can get dispatched onto a different connection on the back end over time. And by doing that, you don't need to have a front side connection pinned to the backside database. Instead, you just open the connection to the proxy, and then when a query comes in, you figure out how to get it to the database. And that's where the multiplexing comes in. The first query on a connection may go on to the database on connection A. The second connection goes on to connection B. So the result of that is you can have a very small number of connections to the database, and that small number of connections will be very, very active. You don't have anything really sitting idle. With connection multiplexing and Heimdall, we have seen cases where customers that literally had thousands of connections go down to, say, less than 20. Okay, and in particular with Postgres, that's huge. MySQL, it's less of a problem, and SQL Server, it's even less still, but even those often can have a significant benefit by using connection pooling. And again, when we look at the breakdown of the features and functionality within the overall feature called connection pooling, you can see that Heimdall supports more than anything else. Although even Heimdall does not handle prepared statement support for transaction pooling. In that case, basically the multiplexing gets disabled if you're doing prepared statements. And to clarify what a prepared statement is, the idea is that you can send a single SQL query without parameters to the database. It compiles the statement and knows how to execute it. And then the application can then send just the variables that fill in that SQL, and it can be reused over and over again. Okay. We also have something called delayed transactions, which we're going to get to in a moment, which is kind of some of the secret sauce that Heimdall provides that nothing else does. Okay, so let's talk about delayed transactions. And this is one of the really interesting features that Heimdall provides. And it technically violates ACID compliance with a database, but it does so in a way that most applications don't care. What we've found with working with customers is that often applications are written so that everything they do is in a transaction. And the idea of a transaction is that it's an atomic unit of work, and any changes that you make within the transaction can get rolled back if something goes wrong without making any changes at all. Now, the problem with a transaction, however, is that once you start a transaction, you cannot be changing what server you're connecting to, and it generally breaks the capability of doing caching. What delayed transactions does, however, is that it attempts to remove read queries out of a transaction when it's safe to do so. If you look at the bottom, the application may have done a begin to start a transaction, then select star from table A, select star from table B, then it inserts into table C values that it computed out of table A and table B. and then it does a commit. Now, we want to be able to cache that select from table A and table B, but because it's in a transaction, we can't. And other proxies have the same problem. But if you think about it, it's highly unlikely that those selects actually need to be in the transaction at all. What delayed transactions does is it waits until there's an actual DML or DDL before it starts the transaction. So that select star from table A and table B, those become cacheable. Those can also now be sent to a reader node in a cluster of database servers. So it doesn't have to be sent to the write master, and thus it reduces the load on the write master. And that can be huge.
I got a question for you.
Yes.
All right, so you're teaching me something today. If I have a select that's in a transaction and that's non-cacheable, your statement about that, is that generalizable to all databases, or is it applicable only to Postgres?
Okay. There's subtleties on how all this works. There are different SQL execution modes. For example, you can have a consistent read SQL mode, which means if you select star from table A and you're in a transaction, then you read the same data from table A again. In that query, that SQL processing mode, you're guaranteed to get the same results. Okay. But there's also read committed SQL mode, which means that despite being in a transaction, if you select from table A and then you read again, if some other thread has committed to that table, you can read something different. By removing the select out of the transaction, we're effectively enforcing the read committed type behavior. So if you need the consistent read, it's not necessarily going to work. However, you can do something like select star from table A and add to it the for update clause. For update is explicitly telling the database, I am going to be making changes against the rows that I just read. Because of that, Heimdall will see that as being something that is required to be in the transaction, and delayed transactions will thus start the transaction to handle the select for update. And that allows you to get around the situations where delayed transactions would have otherwise caused a behavior that you didn't want. Okay, any other questions?
Thank you for that.
No problem. Anybody else have any questions? Julian, Max, Cheng? Okay, thanks. Okay, now let's talk about read-write split. Okay, read-write split is the idea where you're taking and peeling off reads from a write master database without the application being aware of it and sending it to a read-only server. Now, with Postgres and all other databases, you have an issue called replication lag. So if you write onto a write master, unless you've got something called synchronous replication enabled, the write will complete before the reader node actually knows about the data that changed. It went to the writer, but it's not on the reader yet. If you then attempt to read the table that was just changed from the reader, you're going to read stale data. Okay, because it has not been reflected yet. The time to guarantee that the data has been moved over to the reader is what's generally called the replication lag time period. So most people, and then let's also talk about caching. Okay, caching, which we're going to get into. You know what? Let me go back. Okay. Let me restate this. Read-write split, from our perspective, however, is query caching. Most people think that they're two different things. We consider it to be one and the same. To conceptually think about this, think of a reader node in a database cluster as being a cache of all possible result sets. Okay, but just like any cache, it may be out of date as a result of a write against a table. So Heimdall conceptually keeps this model in mind, and we actually build off of our caching engine in order to do read-write split. In order to know that, in order to do this, to do caching and read-write split, we have to know what tables are referenced by a given query, what the last write time on each table is, and how long it takes to synchronize across the nodes. And then we use what's called the pub/sub interface on either Redis or any of our other supported caches. Or with Postgres, we can actually use the notify interface to let different proxy nodes know when a particular table has been written to. By using that, and then we know the synchronization delay, etc., what Heimdall is able to do is it's able to route queries safely to the reader node, guaranteeing that you get the appropriate data off of it, off of the reader, or out of the cluster that you need, and in order to guarantee ACID compliance. Okay, and to really sum it up, any proxy or implementation of read-write split that does not actually provide caching probably doesn't have all the information necessary to do read-write split reliably and consistently. Okay, that makes sense?
So do any examples come to mind that do not provide what you just described?
Everything. Okay. Any proxy that I've investigated that claims to provide read-write split effectively is only guaranteeing eventual consistency when reading from the reader. It is not guaranteeing that you're going to get the right data at any given point in time. The MySQL proxy code base tracks and claims to track replication lag, but what it's doing is it basically is an on-off switch. If the replication lag gets too high, then it will stop using the reader because the data could be too far out of sync. But it still doesn't guarantee that the data is actually in sync at the moment a read is done. It just limits how far out of sync it can be. That's it.
Okay, thanks.
Okay. Now let's talk about caching. Okay. Pgpool-II claims to have query caching. Okay. But all the caches that I've inspected, anything that claims to cache queries from a database, they're all broken. Okay. And that's because the obvious way to manage your cache is the wrong way. You would normally think that when you're dealing with caching and invalidation, let's say you read 10 queries from table A. You store those into your cache, and then you do a write against table A, and that could change the results of anything you got from table A. You would think that you would want to go through and delete all 10 objects, right? Get them out of the cache. That's how invalidation should work, right? except that that becomes very expensive. In order to illustrate that, let's not think about 10 objects. Let's think, say, 10,000 queries. If upon a single write, you now have to invalidate 10,000 objects, that may result in 10,000 round trips to say, delete object A, delete object B, delete object C from the remote cache, be it Redis or anything else. Okay, and that delay can become very expensive and prohibitive. The Pgpool-II documentation itself says unless you're getting over a 70% cache hit rate, you're probably not going to get a benefit out of using its caching, performance-wise. 70%. Okay.
And is it not possible to batch those and send them off all in one go?
You can, but there's another key problem with this. Okay, and that has to do with distributed caching. If you have two proxies that are doing caching, then you may have a write against one proxy node, but the other proxy node has inserted objects against a particular table. Well, the proxy node that just observed the write doesn't necessarily know about the objects it now needs to delete. So you would have to synchronize all knowledge of all the objects and what tables they were associated with between all the proxies, which that's a lot of information, in order to guarantee that you're deleting the right things when you need to. Okay, so it becomes a very difficult data management problem, and you're at risk of the data being out of sync, even in for brief periods of time, and you end up with an inconsistent state, and you end up returning the wrong data. So what Heimdall does is it avoids walking that cache tree completely. Instead, all we keep track of is a per table timestamp that we synchronize between the proxy nodes. And when an object is pulled out of the cache, it includes what tables were associated with that particular object. We can look up the last write timestamp for that query and the creation time of the object. And if it was created before the last write for any involved table, we know it's stale and we can throw it out. Then we repopulate it with a new object. So we only have to touch the objects that are actually active at any given moment. And because we just keep track of those timestamps, which are much easier to keep track of versus all the objects that are possibly there, it results in a lot less chatter between proxy nodes. Make sense?
Yeah, I follow. Thank you.
Okay. So most of these caches, they just used a trivial delete objects when they think that they are no longer valid. And that just doesn't work in a distributed environment. Okay. So let's look at just the cache feature and then all the different pieces that come into play in order to be able to do caching properly. The first piece is, well, just basic caching, and only Pgpool-II claims to support it. And then on the MySQL world, the Postgres proxy code base claims to support it. Pgpool-II claims to do table level invalidation. So it does know what tables got invalidated, but then it tries to delete the individual objects associated with that table one at a time. Okay, obviously that can cause a problem. The MySQL proxy does not even do that. Okay. Another interesting piece in how Heimdall has optimized traffic is that it does two-tier caching. So it keeps the hottest objects in memory in local heap, and then the remote cache, the Redis server, acts as a layer 2 cache. So by doing that, when you have the more common hits, we don't even have a round trip to the cache to deal with. All you get is performance.
How are you saving that in your L1
Okay.
cache?
This is an interesting optimization that we've done. When operating as a proxy, we store the result set as a byte stream that is equivalent to what you would see on the wire. Okay, so basically, as we write the result set to the user, we're saving the write buffers that we use to write the result set, and then we put that into cache, all such that when there's another cache hit, we literally just pull that byte buffer and dump it on the wire. Okay, there's no interpretation, there's no processing overhead. It's extremely efficient. Okay.
Thanks.
Okay, so there's the two-tiered caching. We've talked about the timestamp-based invalidation. Another optimization that we've done is remote key caching, or cache key caching. Redis, and this is an interesting feature if you're not familiar with it, Redis and other caches allow you to set up a notification listener on the pub sub interface. And this is something that is very useful. Anytime a key is inserted, updated, or deleted, all the proxies, or if you use it directly from your application, can be informed that that key has either is now in the cache or it's been deleted. Heimdall keeps track of those notifications and the keys locally, just like it does in the for the L1 cache, and it knows whether or not there's ever even a point to asking the L2 cache if an item is in it. And this is one of those key things with caching is you have to pay attention to the performance penalty that you get on a cache miss. And by doing this remote key caching, we avoid the miss penalty basically completely. We don't have it because we don't have additional overhead on a miss. Okay, this is something that a lot of people could and should implement within their applications, but they don't. It's not something that they think about doing or even know that they can do. An interesting thing, just talking about third-party caches like Redis and such, Redis and Hazelcast both provide this type of capability. Memcache does not. Okay. Originally, Heimdall tried to support Memcache, but we just found that it's too primitive of a cache to even provide good capability and good functionality.
I'm sorry, could you, describe this remote cache key caching
Okay.
again,
So,
and how it can avoid the cache miss penalty?
okay. So what we do, we tell Redis, let us know whenever a cache key is created or destroyed. Now, let's say you've got two proxies. So proxy A inserts an object into Redis. Redis tells proxy B, this item now exists in Redis. So proxy B knows, okay, I can pull it from Redis now instead of the database if I need to. Great, that works. But next, if it gets destroyed, that message gets propagated as well. So whenever we're doing a cache lookup and we get to the point where we're going to do a lookup in Redis, we first look to see whether or not the key exists in our local key cache. If it doesn't, we don't even ask Redis. Okay.
I think I got it. Yeah.
Okay. So by doing that, we don't have the penalty. We just go straight to the database and populate from there. Okay.
Yeah, I understand. Makes
And
perfect sense. Yeah, thank you.
once we implemented that, Heimdall, when we first came out, we did not have this, and we kept having problems showing performance benefits when, say, the cache hit rate was maybe only, say, 50%, because we kept the performance penalty, the round trip time to go to Redis, was often just as bad as going to the database itself. So you had to have like higher than 50% cache hit rate just to even get a benefit to break even. Once we put this into place, almost any cache hit rate can result in a performance improvement because there's no additional penalty on a miss. It makes caching so much more valuable. Okay. Additional aspects to what Heimdall does, we've got table level invalidation API. So if you need to invalidate content on a per table basis, you can. We also support the Postgres listen and notify interface. So we can do invalidation via the database itself. And that can be useful for certain types of topologies and certain types of environments, because it actually means you no longer need a Redis server. So it can help to keep costs down. And then we've got additional options. If you really want, you can enable a eventually consistent option for Heimdall, so that we serve what is technically stale content. But in some environments, that's fine. Okay. Any more questions on caching and auto invalidation? Okay. So read write split, we've already talked about that a little bit. Heimdall again has more features than everything else. Heimdall is rule driven, which Pgpool-II and PgBouncer basically are as well. The RDS proxy supports reader endpoints now. Originally they did not, but it does not do read write split. People get confused on that. It just means that you can have an endpoint on the proxy that points to readers. Statement level read write split, or the connection multiplexing type capability. Pgpool-II and RR do that as well, but they do not have delayed transaction support, and they do not have true replication lag detection, and they do not apply replication lag on a per table basis. It may be safe to read tables A, B, and C from a reader, but not table D, because you just wrote to D. And by having the per table split, it makes the read write split capability much more usable. Okay. Heimdall, along with other proxies, also support monitoring and failover, so that if there's a failure on a particular node, it will be noted, and it could potentially trigger actions external to it in order to resolve the problem. HA proxy has this type of capability. The RDS proxy, it's kind of not even applicable for that. But Heimdall has a full set of features, including APIs that allow it to integrate with orchestration tools. If anybody's familiar with the MySQL orchestration tool, we have APIs that make it very simple to integrate with that. We integrate with the AWS APIs. We actually are able to pull configuration changes directly from the AWS RDS configuration. And that allows us to solve many problems dealing with large scale cluster health tracking in the AWS environment. Is anybody familiar with the DNS issue of using a reader endpoint in RDS? So I'm going to take that as a no. The problem is that the reader endpoint, if you resolve the name that reader endpoint points to, it will only return one IP address at a time, ever. Now, if you only have one reader, there's no problem. But if you have 10 readers, it's a big problem, because a lot of applications will do a DNS lookup, cache the result, and will open all their connections to the one IP address. So you do not get load distribution across all 10 servers. You get one server slammed and the other 10 or other 9 are unused. Okay. Heimdall resolves this by actually asking for the cluster definition from AWS directly via the configuration APIs. So it knows about all 10 databases and what their actual endpoints are. As such, Heimdall is able to load balance all the time, or all the databases, and get an even load. Ching, you're indicating a thumbs up on that, right?
Yeah, that's just wonderful. I mean, wonderful way of engineering that you guys look around and figure out the best solution instead of just rely on an apparent like API or whatever mechanism they provided.
Yep. So, and if we see various error conditions happen, that will trigger an immediate repoll of the AWS API to find out what's going on. And then on a periodic basis, we repoll on every 30 seconds. So it'll take 30 seconds for a new reader to be detected, because there's nothing to flag that an event just happened. But on a failure of a node, we'll reconfigure immediately. So we have some customers that are using at least before Heimdall, we're using the limit on their RDS cluster of 15 readers in one cluster. Imagine the bill that a 12 extra large cluster with 15 readers was. That's a lot. Okay. But with caching and read-write split, they were able to dramatically reduce the number of databases down to like 5.
You mean there are 12 instances of that?
No, 15 instances of R5 12 extra large.
Yeah. Okay. Yeah, that would be significant.
That particular customer was driving 80 gigabits a second from the cluster.
Financial?
Sort of.
Okay.
Yeah. Okay. Big cluster. Okay. Load balancing, another feature that proxies provide. Again, Heimdall provides a full set of functionality, auto reconfiguration of the readers, et cetera, et cetera. Obviously, the AWS RDS proxy also does that, but it doesn't actually do the read-write split for you. So, and it's when you combine read-write split with the auto reconfiguration via the API that the value really shines. Okay. Another feature that Heimdall provides is Active Directory integration. This is kind of cool. If you look at documentation, you'll get the idea that like Postgres supports Active Directory. Okay, and technically it does for authentication. That's it. It does not use it for authorization or anything else. With Heimdall, what we can do is we can actually integrate with Active Directory, do group extraction. So depending on what group someone is a member of, we can then create that user on the database and create the roles based on the groups that they should be a member of. So when someone is added to the HR team and the appropriate groups are set up, they would automatically have access to be able to access data that the HR team is allowed to access on the database. No coordination to actually add the users needs to be done. It's all done in Active Directory. Okay. Any comments or thoughts on that? Okay. None of the other proxies support anything like this. Okay. A bunch of other management and integration pieces. Okay. Heimdall was designed from the beginning to support auto scaling. It was designed to be a clustered architecture. Every other proxy is not designed that way, not really. Okay, aside from the RDS proxy, although I've never really pushed the limit on their claim that it auto scales. Provides GUI-based management. That's trivial for the RDS proxy because it supports so few features. Nothing else supports a GUI, at least not out of the box. GUI for analytics and dashboard. RESTful APIs for configuration, reconfiguration. Easy access to config via JSON files as well. And then other ease of use integrations for AWS.
I got a question for you.
Yes.
It just comes off that REST API. Do you have an event-driven API? To where, like, for example, if my entire application was using Heimdall, and for example, we were pointing at a database that did not support event-driven change notifications. Instead of getting it from the database, which doesn't support it, I could get it through Heimdall.
We do have the ability to log queries that are happening, and you can filter that by rule. And if you wanted to, it's actually part of a feature set that we call kind of proxy side triggers. So you can trigger actions to happen as a result of particular queries coming through. It could be executing of an external program, or it could be, for example, just doing an insert into a table on the database itself. Okay.
Yeah, thank you.
Yeah. And then dealing with logging and audit capabilities as well. It's often good to have your layer of indirection dealing with the auditing of what's going on, because you can give different people access to those audit logs that are on the database. So you can have someone watching the watcher. Okay. Whereas if someone can get into the database and you're doing your auditing on the database, then they can potentially change the audit trail. Okay. We can, even if you wanted to, log the actual result set for queries selectively based on the column that was being pulled. Okay. And lots of other features that are out there. We can extract the query plan. We've got query firewalling. You can even do query throttling. One feature we don't have at the moment is data masking, but it has been discussed, and we have the appropriate infrastructure where we could start doing data masking. We're just looking for a customer that wants it at this point.
Can you explain what you mean by that?
Okay. Social security number gets stored.
Okay.
With the full information. When you actually have a query that returns a social security number, it masks out everything but the last 4 digits, for example.
Okay, that makes sense. Thank you.
Okay. Yeah, social security numbers and ID numbers are clearly, and credit cards, clearly the case where would be important. Okay, and we don't do replication. Pgpool-II does fine. Okay, we'll give it that one because you don't need it anymore. It's in the database. So when should you use what? Okay. I'm not going to go through all these. I'm not going to read them all off. It'll be in the recording that we can post. But in general, anything other than trivial cases, we're probably going to recommend Heimdall. But if you're just trying to reduce the number of connection opens per minute, you know what? Anything aside from HA proxy can deal with that. If all you want is failover, do HA proxy. Okay. But I think I've kind of reiterated the point that a lot of the fancy features that these other proxies support, they kind of only support it in name only. They don't actually have the functionality you need to use it. An example of how to do a deployment within AWS, you'd use auto scaling to set up your database proxies. They would point to your primary and standby nodes, auto reconfiguring as needed. And it just becomes a very nice and elegant setup where you're only paying for the proxy capacity you need, and it'll grow with you.
And that DB proxy is Heimdall.
Yep.
Yeah.
So now, I guess I should update the slides as RedisConf has come and gone. We were presenting at the Redis conference, and we had a different presentation there. There should be some, the video will be posted at some point in the near future if you're interested in seeing what we talked about there. We do have a 30-day trial on the various cloud marketplaces. AWS, Azure, and Google were in their marketplaces. And we can also operate on-prem. And if there's anywhere else you need us to run, just contact us.
So if I, just for sake argument, if I want to set this up with just out of the box configuration for a web application, what were we looking at? Like maybe an hour or two, maybe more?
Oh, I can generally set it up on a Zoom call with someone within an hour.
Yeah.
And have it online and ready to test.
Okay. Thank you.
And we generally put an engineer on for anybody that requests it and help guide you through the process, because we can make things a lot easier. We know what to look for.
All right, thanks. That's helpful.
Okay. And that's it. If you want to see a quick little demo, if we have time, and everybody's interested, this is our management console. I have an application called Udo, and I've got a traffic generator running against it right now in order to give us something to work with. I'm just going to demonstrate two features very quickly, read-write split and caching. Everything is rule driven. So literally this cache rule right here, I'm simply going to enable it. There's no specifiers, no nothing. It's intelligent enough to take that and work properly in order to turn caching on for this third-party application. And you can see what happens as the cache hit rate goes up. The black line represents the database response time. The blue line is the overall response time. And what I want to call out here is that when we reduce the load on the database, it performs faster for the remaining queries. Okay, and you can see the number of queries per second that actually got to the database went from about 900 to 1,000 down to about 100. Okay, so you're able to focus the resources on the remaining non-cacheable queries. So that's great. Okay, we can also come here. I'm gonna turn it off so that we see it go back to normal. We've got the load on the primary again. I'm going to come in, I'm going to turn the rules, I'm going to turn reader eligible on, and this is going to enable the read-write split. Okay, so now the blue line, which was the primary, most of the queries are now going to the standby, the secondary server. Okay. And again, it's intelligent enough that in most cases, literally that one rule is all you need to do to turn it on. Okay. Now, we can also combine these two. This is a little bit of an interesting side effect. And it kind of highlights the fact that read-write split and caching are two sides of the same coin. Well, notice that the cache hit rate is consuming from the reads on the secondary. The primary still has the same load.
But the primary is doing the write, correct?
Correct. Okay. Anything that's not a read. Now, in this case, pretty much all the reads are being consumed by the cache. That's not always the case. Let's consider a query that contains a timestamp. That timestamp will be changing all the time. So as a result, the read-write split would allow that to go to the reader, whereas everything else would go from the cache. And that's actually more efficient for Heimdall to serve out of the cache than to process the full request. Okay, so quick little demo. One final piece. Yep. Let me turn the rules. So I'm going to turn logging on so that I have some data for my analytics. Come over here. Rule log. There's something going on with this. Actually, I've been playing with a different version of code, so the database is probably not working quite right. I'll have to fix that. But normally you would get an output of all the results here. You'd be able to see all the queries, the performance, etc. And it helps you to find the hot spots that you may need to optimize as well.
Sounds neat. Sounds neat, excuse me.
You can see all the logs, for example, here. So let's see. Yeah, I'll have to play around with that. I downgraded from a test rev of code on this machine, and I don't think it liked the downgrade for the analytics.
So when a SQL string comes across the wire and you intercept it, are you converting it into some kind of object equivalent?
No. We are passing it through unmodified. Even comments don't get stripped out because anything that changes the query could change how the database processes it. You would think that things like comments are safe to strip out. Nope. Sometimes they actually matter. So.
Okay.
Okay. Anything else?
Well, not a question. I think this is like wonderful presentation, and you describe the software very well.
Okay, thank you.
Yeah, I'm from software engineering, even though I'm a data engineer now, but from a software engineering background. So I can see this is a really good software engineering a project that successful and shining. So thank you very much. It's so careful considerations, not only in the principle or theory level, but also consider the practical, like different, because anyway, your software live in an environment like the AWS RDS, what their features and how to handle that. So all these areas you considered carefully and did a wonderful job. Thank you very much.
Thanks. So yeah, it is interesting the sheer number of variables that we have to deal with, because we're dealing with, say, Postgres, MySQL, and SQL Server. They're binary protocols we have to parse. Different versions of the protocols we have to deal with. Different versions of the databases behave in different ways. The different environments, whether you're running an AWS versus an RDS versus self-hosting the database. All the different variations of how you can do things, like you can execute raw SQL, you can do prepared statements. In the case of Postgres, you can have a binary versus text representation of the result set be returned. It's a huge number of variables, but we've accounted for all of these, and we try to make it as drop-in as possible into almost any environment.
And I have a question about, like, not directly related to the product itself, but about the development process. And how large is your development team, and how long it takes for you to get to this point?
We've been working on this. It's a small team. I don't want to go into exact numbers, but it is a small team. But we've been working on it for about 6 years.
Wow. Impressive. Very impressive.
It's taken a long time to do what we need to do. One of the interesting things that actually resulted in us being able to more easily support this with a very small team is actually how we started and how we built the product, and then a pivot we made. The original product was originally designed just to be a JDBC driver that implemented these features. Okay, now, given that a JDBC driver implements into the application stack, and the stack has more than one application server, that's what made it, from the beginning, designed to be distributed. Now, we got the basic features up and running and started trying to sell it. There weren't enough people that wanted a JDBC driver to do this, but we got a lot of people saying, hey, we've got a PHP app, we've got a Ruby app, how about implementing there? And we're like, well, no, we've got a JDBC driver. If it doesn't use a JDBC driver, we can't do it. But one day we said, you know what? Can we parse the protocol of the database and effectively reverse map it to the JDBC API? Okay. And we started with MySQL. And honestly, I had no idea if this was even going to work. We just did it. Okay. If you actually asked me to place bets on whether or not it was going to work, I would have bet no. Okay. However, we made it work. So instead of maintaining, say, a separate cache engine for MySQL, a separate cache engine for Postgres, separate cache engine or read-write split engine for SQL Server, we translate the protocols all back into JDBC, and then we implement the functionality in that same JDBC core that we built originally. And in fact, we can still run as a JDBC driver as well. And we can support Oracle, DB2, other databases that way.
Is that off one driver, or do you have like a unique driver per database?
It's one driver.
Oh, that's interesting.
Okay. The way that it operates is as a shim layer between the application and the vendor JDBC driver. So in fact, if we go into our configuration, you look at the data source, you can see you actually specify a JDBC URL as the data source, and we have JDBC driver configuration. So we use this JDBC driver to talk to the database. And that also helps abstract away problems, because you can have new versions of the database added. And as long as there's a new driver that supports it, we can generally transparently add support for it.
So basically, your JDBC driver becomes sort of like a proxy between your build up software, which doing the proxy work, and the real physical database.
Yeah. So within our code, we have separate proxy modules that do the protocol level translation, but then all of them just funnel into the JDBC driver in order to implement the features.
And from an application developer's point of view, how much does the application need to know that it's actually talking to a proxy and not directly to the database?
It generally doesn't need to know at all. You just change the connection string.
Mhm.
Yeah.
You change the connection string simply to point to the proxy.
Yep. Or in the case of an auto scaling group, the load balancer endpoint.
Okay.
Okay.
And are there any constraints when it comes to functions or stored procedures that they are routed correctly to the correct nodes?
Well, first off, if you talk to database purists, we are the Darth Vader of software. Okay. We definitely operate in the dark side. We allow you to shoot your foot. We allow you to do things that are going to break your app. Okay. We allow you to do a lot of stuff. Okay. But that means that the database guys don't have to worry about letting you do this stuff. Okay. They don't like having features that knowingly will potentially break things like ACID compliance. They hate that. So there are constraints on what you can enable when, like the delayed transactions. That's definitely a dark side feature. Okay, but if it works, it can provide wonderful benefits.
Mhm.
Okay. As far as other things, there are some very rare corner cases that we cannot support. But these are corner cases that really, really were never considered possible through a proxy. Like there are things dealing with multi-phase transactions, dealing with multiple databases that you're not going to do through us. Okay, sorry.
It's like distributed transactions.
Yeah.
And it's a very hard nut to crack as far as I understand it.
Yeah, but most people don't need that. Yeah. Okay.
Yeah, thank you.
Thanks.
Anything else?
Thank you.
Glad to be here, and thank you, Thomas, for inviting us. And I know that it was a small group, but hopefully more people will see us online.
Yeah, we'll do it again sometime. And thank you very much for taking the time out to give us a nice presentation and describe these benefits and discuss the other stuff about the traffic management with Postgres.
Well, thank you.
Thank you very much.